Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geek for Geeks for 6th February 2023. The problem statement for today is BST downward traversal. This is based on tree concept binary search tree. So let's open the problem. We will go through the problem statement clearly once. The problem statement says, given a binary search tree and a target value, you have to find the node whose data is equal to target and return the sum of all descendant nodes data which are vertically below the target node. Initially, you are at the root node. Okay. It is given if target node is not present, then in BST, then return 1. Okay. So here basically we need to find the sum of all the descendant nodes which is directly below the target node. So for example, here the target node is given as 35. So this is the target node. We are initially at root node which is 25. So we need to first find this node, and then we need to find which all nodes is coming are coming directly under this one, vertically down under this target node. So here we can see this node is 32, which is coming directly under this node, this particular node which is the target node. So here the output is 32, the vertically below 35 is 32. So here we need to take care of one concept. That means whenever we talk about binary search tree or BST, then we can see that whenever we do in order traversal of the tree, so it will always be in sorted order. So in order traversal means first we will traverse the left subtree, then node, then right subtree. So following the same approach, if we do the similar traversal in this entire tree, then we will get entire element in the sorted form. First it will be 15, 20, 22, 25, 30, then this one. If when we are coming directly under this, then left of this one it is null. So left subtree it is not considered. So next it will become 30, then 32, then this will become here as 35. 35 will be taken. Then after that this 45. So we can see this will become a sorted array if we do the in order traversal. Each time we have to take first left node, then then root node, then right node for each subtree in this one. So here the basic the basic concept or approach which we will follow in solving this question is, we will see as we already know all the elements will be in sorted order. So we will first compare it with that root node. Then we will see that whether that particular target element is to the left of it or to the right of it here. So as the target element is given as 35, first we'll compare it with 25, which is the root node. Then we can see, since the root node is smaller than the target element, so that has to be present on the right node. So once we traverse to the right node, then we can see we will get this one. Then once we get the target node, then we have to find all the elements which is vertically below this, all the elements or all the nodes which is coming vertically below this. So if for this example 35, we can see 32 is vertically below this one. That's why the answer is 32. Let's look at the second example. So here here it is saying the target node itself is the root node, which is 25. So here once we are taking this into consideration, then we have to find all the nodes which are coming vertically down to this one. So here we can see these two nodes, this one, these two nodes 22 and 30, these two are coming vertically down to this one in the same axis. So that's why the answer for this will be 30 plus 22 is 52. Let's understand it in a better way with one diagram. So for the first example where it was 35 as the target node, so here we can see 35. If we draw one axis here, that means this one vertically y axis and this x axis. So if we consider that this one is that this vertical line is at index position 0, that means axis 0. So whatever is coming to the left of it, we can mark it as -1, and whatever it is coming to the right of it, we can mark it as a +1. So what we can do, so here each time when we iterate, when we traverse through this given tree, so all those elements which will be at the same level of y-axis, that means where that axis the x-axis position will be 0, so all those things we will take into consideration, and we will do the sum of it. So keeping this in mind, so let's start solving this problem. Okay, so here first we will start with, since we have been given root and the target here, so we will first start our solution taking into consideration till the point when root becomes null. So when root not equal to null, we will do the following steps here. Then we can check if data of root, that means root dot data is equal to target. That means if our target is at the root node only, then we can do some operation here, that I'll come to it after that. But if this is not the scenario, then we'll check here that if root dot data is less than target, if root data is less than target, sorry, this was not needed, yeah, then we can assign root as root dot right. That means if the root data is less than, if this root data which is 25 is less than the target element, then we can make this as root for that subsequent operation. So now our new root will be 35. Similarly, if, or directly we can write only one operation, one scenario is left there. So in that case, we can make root as root dot left. This scenario will cover whenever the root data is greater than the target. That means root is greater than the target, then at that moment we have to look for all the vertically downward elements in the left subtree. So that's why we are making the left subtree root as the new root that has to be taken into consideration for finding the solution for this one. That means summation of all the vertically downward nodes element, data of those particular thing. So if these two are the things, then, and else if we cannot find this element there, then we can simply return -1 here. So now whenever that target element is present at any of the root, so what we can do, we can search for all the nodes those are coming vertically down to it, search node, then, and here we can pass root, we will pass the root node, and there we will pass this axis considering that as 0. So let's go to that this image again, this is drawing again. So whenever we got this root node as a target element, so we'll mark that this is coming at x-axis position 0. So if, and now while iterating, if we get anything on the left side, then we can mark that as -1 axis, and if anything coming to the right of it, so we can mark it as +1. So if 45 is having again some one left node, so that will again come to this as axis position 0. So taking this into consideration, I'm just sending the access node here as 0. So now what we can do, we can create this method whatever we have created here, that means this search node. So let's create this method here, void search node. Here we will accept the node element whatever we are passing there as root, this whatever we are passing from here, that is coming as root, and let's give this 0 as some variable name as access. We can write just some variable name. So here we can check if root is equal to null, then we can't do anything, we can just return from here. That means no operation is there to be performed by us, so we can return null. But if we get something where access is 0, so all those nodes we have to take into consideration, and we need to do summation of that thing. So we can do sum is equal to root dot data. So we are interested in all those nodes which is coming at axis 0. That means, so only those will be considered as coming vertically downward to the target element. If anything is coming to the left, then axis for that will be -1. If anything coming to the right of it, then axis will be +1. So we have to completely discard them. When the axis becomes 0, that only we have to take into consideration for finding the summation of all the vertically downward element of the target element of the target node. So if this is the case, then we will do this. And for checking all other nodes which are coming directly vertically down to it, we have to first look at it in the left subtree and then for the right subtree. So for looking for such elements in left subtree, we can call this method recursively, calling search node root dot left, and here we will pass axis -1. Once this is done, then we need to look in the right subtree, and here we will pass root dot right, and here we will pass axis +1. Okay, we need to initialize this sum, since let's define it globally. We need to return, okay, we are returning so let's assign this one as long sum is equal to 0, and here from here, once that searching is done for all the subsequent all the nodes which are coming directly vertically downward to that particular target node, in that case we can return sum minus target. So here actually the question is to find the sum of all the elements which are coming vertically downward to it, and we do not have to include the target element. And if you look here, so in a particular subtree, that means wherever we get the target node, we are adding all the nodes which are coming in the same axis. So if it is 35 and 32 coming in the same axis, that means at 0. So here we are doing summation of 35 plus 32, but actually what we need to return, all those summation of all those elements which is coming vertically downward to it, excluding it. That means all those elements. So here only 32 will be there. So the summation of it will be 30. This one 67. In that we need to subtract 35. That is the target node. The same thing I have just written here. Okay, so we are pretty well done with our coding. So let's try compiling this code. something. End of the file reaching parsing. This is here. This is here. Okay, so this one is not closed. Okay, so let's try again. Okay, so we can see we have got our result. So now let's try submitting this solution. Yeah, so we can see we have cleared all the test cases for this problem statement. We have solved it successfully. So yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.